DKGcon 2024 in Amsterdam. I'm super happy to have our advisor, Professor Dr. Bob Metcalfe, on the video with us. Hello, Professor, and how are you feeling? How's your morning going?
Well, one of my dogs has wandered off and is missing, but other than that, everything's fine.
Oh, okay. Best of luck to you to resolve that situation. I hope it's not anything serious.
If I
What
seem
is
fidgety, it's because I'm nervous about my dog. That's all.
Yeah, well, best of luck. Best of luck for that. For those of you who might not know who Professor Dr. Bob Metcalfe is, I'll just give a very quick intro, but I definitely advise you to look it up. Basically, he is the man behind the technology we're using, not only to record this video, but also to cover the conference, to communicate every day. He has brought connectivity to the world with the invention of Ethernet, one of the most important protocols ever invented, basically bringing us all online and laying the foundation for internet. Also winner of many awards, such as the Turing Awards that you won last year, which is impressive, and congratulations once again. But many others, professor at MIT, professor at UT Austin, if I'm not mistaken, and probably many more accolades that I cannot even start to mention. So welcome again, Professor. Super happy to have you, and especially here at DKGcon to share your experience, your thoughts, your views on where the world of technology is heading, especially in the domain of AI. So yeah, let's just get started. You're obviously famous for inventing Ethernet, and I've also caught a tweet you posted recently, very interesting sort of reveal on X, how you actually did your bachelor thesis in something else, which was called, if I'm not mistaken, a neuron model and its information processing capabilities. This was back in 1968. So basically, yes, you became famous for networking, but you were already on track with AI back in the day. So curious what
Well,
came from that and how did that come about?
let's not spend too much time on this, but I haven't always been a networker. In the mid 60s, I was taking all of the artificial intelligence, and they were called AI classes at MIT. And for one of the classes, my fraternity brother, Ernie Szilagyi, and I wrote a program for the TX0 computer, which simulated elementary life forms. And it attributed to them some degree of intelligence, like they avoided the sun and they ate food and so on. So I took the rest of the courses and I ended up with, I got an advisor, Marvin Minsky, who was one of the early proponents of artificial intelligence. And he became my undergraduate thesis advisor, for whom in the June of 68, I needed to produce this thesis. And I wrote this thesis on a school bus returning from a varsity tennis match. Got it typed up. Title was a neuron model, as you said, a neuron model, and some of its information processing capabilities. I still have it, by the way, if anyone's interested in reading it. I don't recommend reading it. It's quite old. It was written by an undergraduate who was playing varsity tennis at the time. So it was, in any case, Marvin accepted my thesis, and but he didn't like it very much. I could tell. I mean, he didn't say I don't like it, but I could tell he didn't like it. So that sent me on the 9th floor of Tech Square. I went to the other end of the 9th floor and hooked up with a professor called J.C.R. Licklider, who was one of the bright lights of the visioning for the internet, and I became an internet guy. And my first assignment was to build hardware to connect MIT to the ARPANET, which I think of as Internet 1.0. And the purpose of the ARPANET was to provide a way of resource sharing. ARPA, the Advanced Research Projects Agency, was tired of buying a PDP-10 computer for each of its researchers. So it thought by building this ARPANET, we could connect dumb terminals to any of these PDP-10s and other machines in the ARPA community. So I connected MIT the dumb terminals there, and then I moved to Xerox Research in 1972. And at Xerox Research, we were abandoning slowly dumb terminals and we were switching to personal computers. So we needed a network, not for dumb terminals, we needed a network for personal computers. And that was the biggest stroke of luck I've ever had in my life, is they gave me the job. Since I had done the ARPANET thing at MIT, I was the natural choice to do the what turned out to be called the Ethernet thing at Computer Science Lab at Xerox PARC. So that's how I got into the networking business. And to make a long story short, I was at Xerox for 8 years and we built an internet. You would recognize it as an internet inside of Xerox. And then I started in 1979 by founding a company called 3Com to help build the internet outside of Xerox, the one you're using today. And is that enough? Have you had enough yet?
No, it's I don't know. It's never enough. It's so interesting to listen to all the stories and the history of how it all came about. I'm particularly interested in. I always wanted to ask you more about Xerox Spark, but I'm curious. So you've seen AI since basically '68. You've actually went even deep at the time with it, and you've also seen the internet grow. On that, listening to your conversations, both within our ecosystem and also on your Turing talks, you identified, and you like to call it pathologies that came about over the course of this development. I'm curious, why pathologies, and what would you identify as pathologies, so we can introduce the notion here to the crowd at the conference?
Well, and we're going to see this time and again, as AI was coming and going. AI comes and AI goes, and it's been doing that at least since 1966, coming and going. While that's been happening, the connectivity has been spreading and very rapidly. In fact, some could argue too rapidly. And a consequence of that rapid expansion of availability of connectivity are a number of pathologies, unwanted consequences. And the very first one, which occurred in December of 1973, and I wrote the memo documenting it, was the first hack of the internet. So those bastards have been hacking the internet since 1973, and we still haven't figured out how to stop them completely. But despite that pathology, the internet grew, despite our not having solved completely that pathology. We started using passwords back in '73. That was our remedy then. The internet grew, and the next pathology to crop up was pornography, which is always an early arrival at any connectivity situation. And the United States government almost shut down the internet because it was so good at carrying pornography. And then there was a big kerfuffle in Washington, D.C., and a law was passed, the Communications Decency Act, which sought to solve the pornography problem. A year later, the act was found to be unconstitutional. And I'm fond of saying, as a result of that, there is no longer any pornography on the internet. And then the next, while we were handling those pathologies, along came another one. It's called advertising. Those of us involved in the early construction of the internet were offended when people started using it to advertise their, emails, crass emails, advertising their products, or websites eventually that started advertising. So we were very upset by this new pathology. But then we discovered that the entire internet would be financed by advertising. So companies like Google and Facebook showed that with advertising, they could fund their own growth, the installation of optical fibers. The entire internet was financed by advertising. So it stopped being a pathology, although spam is sort of the residual pathology there. We don't talk about spam that much anymore. It's pretty much under control, but not entirely under control. And then, of course, we have the more modern pathologies. So fake news is sort of the big one now. So there are the pre-existing pathologies, but now there's this new one called fake news, and we're all busily trying to solve it. Do you want to hear my solution?
Yeah, I would love to.
all this effort is going into asking Google and Facebook and LinkedIn and so on to filter, get rid of this fake news and filter it. And we have a big argument. But there's two mistakes being made there. One is we making a mistake by asking them to solve this problem. And second, they made a mistake in agreeing to accept this problem. The big advertisers should not be, we should not rely on them to filter fake news. And the solution is, of course, the obvious one. There should be an app for that. So what we need to do, and people are working on this, is you give the design of your filter to the users, not to the providers. And so imagine apps in which you would compose different filters, like the New York Times filter, and you could have your own filter, and you could add it, so you could sell lists, distribution lists, and then compose them with an app with a drag and drop kind of thing, so that each person could design their own filters, and then we wouldn't have to we wouldn't have to sue Google for misfiltering our input. Anyway, what do you think? Isn't that the obvious solution to this problem? There's an app for that.
It's a very very good way to put it. I absolutely agree. I mean, it is going back to the pathologies you mentioned. Some of those approaches haven't shown so successful. For example, when advertising came, yes, it turned into something that started adding this economic layer to the internet, as you mentioned in one of your previous talks. You mentioned security layer was missing because when you built it as a graduate student, you didn't think people would attack things. Then the economic layer was missing, and now the kind of this truthfulness layer is missing, right? And then so we need to add the truthfulness layer somehow.
Graduate students tend to think that the world is populated entirely by graduate students, but it isn't.
Yeah, it's interesting. I mean, I remember talking about this with you and how internet has evolved. Like until very recently, HTTPS wasn't the default thing. Like you would type in a password and just like plain text that goes through HTTP without any encryption, throughout the network, and everybody listening in can catch it. And that was pretty recent. I remember that. I'm that old, but I'm not that old. So, but yeah, in terms of the truthfulness layer, I think you're absolutely right. Where advertising, though did go in somewhat of a good direction, it also did produce problems such as Cambridge Analytica and all of this data privacy trouble that was caused by it, that ultimately has a societal influence that can influence elections, which is obviously a huge topic coming a couple of weeks out from when the conference is in. So really the layer here cannot be, like, you cannot have the ones who are responsible for such a technology also regulate themselves in a way. And in our opinion, as the ecosystem of OriginTrail, it is really about putting the power into the user's hands. So actually a lot about what we're being...
This filtering app, this composable branded filtering app that I'm expecting to come along pretty soon, can use AI. So you could imagine some very sophisticated and clever filtering schemes developed through the use of AI. So that would be a new plus application for AI, is AI can be the solution to fake news through these filtering apps.
Absolutely. And if you are able to control it yourself, so you as a user can modify it if it's open, if it's truly open, that you can configure it, you can run it on your device, you can be sure that it runs the way you want it to. This is really the way to go. And actually, there's going to be quite a lot of talk about exactly what is the way to build that app today at this conference. But before we reveal too much, I'd actually also like to just mention that this pathology that you mentioned, fake news, could be one of the strongest, the biggest so far, in our opinion, because yes, spam was problematic, and obviously the other ones that you mentioned were tricky. But as the technology was growing, as there was more connectivity in the world, technology had a bigger impact, obviously. So social media incredibly impacted the world, and some people would say it polarized us. there's an obvious societal effect. What happens when on those layers we put misinformation and problematic sources really into play? So it's probably going to be one of the biggest anomalies. And which brings me to another interesting topic. As connectivity grows, we see some other effects. Like connectivity can be a catalyzer, and it should be a catalyzer for good. For example, that happened with computer networks. So as famously coined in the Metcalfe's law, which obviously I'm sure you were expecting to come up in this conversation. And I know you had a very interesting analogy, and also like applying Metcalfe's law onto neural networks. So what is your hunch really with Metcalfe's law and how it applies into the world of artificial intelligence today?
Calling it a law makes it really sophisticated. But underneath it all is the simple recognition that when you connect things together, you make them more valuable than when they were disconnected. And connectivity is a very big topic. We've already mentioned neural networks. Well, the word network is a connectivity word. Neural networks are based on connectivity. So imagine the layers of connectivity. So you have the internet in here, and you have fake news up there, and you have Ethernet down here. And then below Ethernet, you begin to have the LLMs and the neural nets. And I think a lot of the progress in AI will be an increasing connectivity down at that level. And I would estimate we're only a factor of 10 away from AGI. That is, the human brain is 10 to the 11th neurons, and the various chats are operating at last time I checked, we're down a factor of 10 from that. We were expecting a new factor of 10 of parameters to come along. So connectivity is proliferating even at that very low level of the neural net itself. And as I said, I'm currently estimating another factor of 10 is required to get us to something resembling human intelligence.
That's a very interesting point, because I expect a very big debate today at the conference, as we have many experts joining in from all over the world, actually arguing that we're seeing kind of a slowdown in the way LLMs perform as they grow. So we train them with more and more data all the time, and actually they start to not only sometimes deteriorate because of the problematic data coming in, that the problem of model collapse that we might touch upon also, but that also the fact of the matter is that there's, with more data and more compute, they're actually not scaling as we were hoping to.
I said earlier that AI comes and goes. And repeatedly in the past, an AI has gone. That is, when it sort of was hot for a while, then it wasn't hot anymore. Repeatedly, it was a shortage of data that killed AI in the past. And so the reasonable question to ask is, that in this current AI boom, will it run into what you call it model collapse? It might run out of data. And that is, we would get all these GPUs running at all those gigahertz and just not have enough data beyond a certain point, and that we would suffer model collapse. I tend to be optimistic about this. The preceding generations of AI that came and went didn't have the internet. But this generation of AI does have the internet, and it has everything in between. So that there's the hope, is that there's enough communication, complex connectivity around to provide the data that's required of these AIs, so they don't go and they stay with us. In particular, they stay with us for filtering fake news. Incidentally, I am addicted to social media, and that's not a joke. And I'm not the only one who's addicted to social media, and that addiction is not healthy. And so I'm going to have to learn, and I think a bunch of other people are going to have to learn how to not suffer the negative impact of spending too much time on the internet. You know that there is that app here that tells you how much screen time you're spending in each of the apps. if you haven't looked at it recently, take a look. That's how I discovered I was addicted. I was spending 8 or 9 hours a day looking at I think I'm down to 4 or 5 hours a day, which is still way too much. So there we go.
It does pull you in, absolutely. I know for a fact a similar metric applies to me and the folks who I work with as well. Yeah, connectivity is very powerful. I think what we're yet to see is the connectivity applied through multiple layers. So like you said, we connected machines, we connected people, we're now connecting AIs. And not just that, we're also connecting different data. So data in its raw form versus data that's actually connected is also another order of magnitude of differences. And that's why this conference is actually a conference about connected data, about knowledge graphs. And what we really see is that ultimately, neural networks are as good as the data we put in them. So with the approach of layered connectivity, we're able to go into the direction, as you said, making the app that will actually help us tackle misinformation. And today we're going to present elements of that as well. It's interesting because when you think about it, one might sort of relate that to the world also before the internet. And I'm curious what your views on it, because today the internet is kind of a default, right? We are all used to being connected. Like I think people who are, I don't know, start to take a phone or a computer in the last 10 years, they don't even use it offline at any point. So we're kind of used to it. It's part of the nature of the device to be connected. And I'm curious, in terms of AI, we haven't seen that yet. So there's AIs that are kind of disconnected. What do you feel? How can we apply connectivity in that sense? And would we have kind of a network of agents on the internet taking over instead of, let's say, people being the main driver behind it? What's your opinion?
So the rapid growth of the internet has led to this series of pathologies that we've just touched on briefly, fake news being perhaps the biggest, most recent one. But there's another one called hallucinations. That is, our current statistical AI regime admits to false data being returned. I think they're frequently called hallucinations. So the question is, how do we deal with that pathology? How do we solve it? Now, back in '68, there was, as far as I could tell, there was no statistical AI. It was all symbolic, and the emphasis was on reasoning and later knowledge representation. So now we have two worlds. We have statistical AI and we have symbolic AI. And it looks like the symbolic AI is, when you combine it with statistical AI, is how we deal with that pathology of hallucinations. And the DKG is the technical mechanism for combining those two worlds. Take it away, Branimir.
Yeah, absolutely, Professor. It's great you position this as another pathology, because it really is. The LLMs, though they're great, but especially being creative, it's weird to think that they're the kind of the only way to AGI, when you cannot ask it a simple question like, for example, who's the Prime Minister of Netherlands, and it actually might give you a wrong answer. So you're never sure because of this statistical nature, and it's in their nature. It's hallucinations are a feature; they're not a bug. So what we really believe at the OriginTrail and the wider ecosystem believes is that this synergy of neural and symbolic, statistical and symbolic AI is the way to go. So that's actually going to be the highlight of the conference today. And it's interesting because that they kind of seem to cancel each other's problems, but both rely heavily on connectivity. Knowledge graphs are also embedding essentially connections between different data points, or as they're called in the world of OriginTrail, knowledge assets, because we see knowledge not just being as a higher order of data, of structure and meaning, semantics essentially ingrained in the data, but also as something which is a new asset class. We believe knowledge is the asset class of the 21st century. You could argue AI is a major consumer of knowledge, and that these knowledge assets will be one of the key elements to which we can build solutions on top of the internet stack that add the layer that combats these pathologies, like you mentioned, hallucinations and fake news. And yes, I'm very excited to be seeing today many builders actually building on OriginTrail. We have 10 presentations of different builders today. So with your experience of building the internet and all of the RFCs and different societies at different universities like MIT, which by the way is incredible. I was just there for the first time last week, where we won the award at the Decentralized AI Summit with OriginTrail. It's really a great place. So with all your vast experience, what would your recommendation be to the builders of this technological layer, and what should the principles be on what they should focus on when they're building and solving for those pathologies?
Well, you'd expect me to say this, but I'm going to say it anyway. You start with connectivity. Now, connectivity creates problems, these pathologies, but it solves many more. And and connectivity at many layers. So it's a very big topic, as we've already mentioned, all the way down here at the, I met with Jensen Huang a few months ago, and in the course of our interview, he apologized because his company, NVIDIA, had chosen InfiniBand and not Ethernet as its connectivity thing. And he apologized to me, which is kind of funny. And I accepted his apology. But then I told him, and don't worry, you'll be on Ethernet soon. And the reason, there's like two basic reasons. One is, of course, Ethernet is superior to InfiniBand, but that's my opinion. But there are these layers again. So one could imagine InfiniBand in the lower layers for super low, high throughput and super low latency, and then Ethernet at a layer higher up, where the emphasis is more on interconnecting with the outside world. So there's room for both InfiniBand and Ethernet in this and you'll find that over and over again, where the complexity, the connectivity recurs at different places in that very tall connectivity stack.
That makes for a very good point. The internet is multiple layers, and so absolutely makes a lot of sense. I do remember though Tesla is using Ethernet, so it's not that InfiniBand all of a sudden is becoming more adopted, is it? Like I believe Cybertruck is all about Ethernet, if I'm not mistaken.
Well, Ethernet is 50 years old, so it's everywhere. And by the way, NVIDIA has announced some weeks ago their Ethernet products. So that's not a head-to-head battle between InfiniBand and Ethernet. It has been from time to time head-to-head, but now, they each have their layer where they're especially efficacious. And so Jensen's apology was appreciated, but not necessary.
Amazing. Thanks a lot for joining us, Professor. I'd love to also finish with a kind of a wrap up and looking into DKG as the technology. You've been helping us a lot build it over the past several years, and thanks again for being an advisor to both us and the entire ecosystem of builders. In your opinion, I know we've been together with many other experts at Knowledge Graph conferences before. I'd love to hear what's kind of your hunch. How big are knowledge graphs going to get, and what do you see as? Do you see them as kind of the new connectivity breeding ground for AI?
Well, I think LLMs and knowledge graphs are made for each other. They solve each other's pathologies. There's very complicated calculations to be made as to what should be standardized in that process. There are a lot of lessons to be learned from things like Ethernet that apply directly to this convergence of the DKG with with the LLMs and all the initials. So build it and they will come. Standardize where you can, because that really accelerates development. Ethernet is a standardization story. It achieved its dominance through being open and interoperable. And so the blockchain, you know, do you remember when blockchains used to be really important and everyone talked about them every day? Well, blockchain is a key component of this, and it'll, as you know, and will help in the construction. And the RAGs have come along. The RAGs is sort of the portal to this unification of the DKG and the LLMs. I mean, the subtlety there is the LLM has to detect when it really needs to call some symbolic AI to answer a question for it. It needs to be able to detect when that's going to happen. And I think the RAG world is preparing for that. And anyway, as you can tell, I'm not a DKG expert. I'm a DKG enthusiast, and I look forward to hearing what you all conclude at the conference.
Thanks a lot for joining us, Professor. It's been a pleasure, like always. Looking forward to hopefully see you next time in person. And by then, I hope the whole dog situation gets handled pretty quickly. Best of luck, and face on. Have a great rest of the day.
Thank you very much.